So, we're going to get the wee pins and all. So a pin out of 21, long leg of the yellow LED light. The other leg goes into the breadboard, just a random column, which is 22. The columns of the breadboard are all connected up, so our little resistors connected into the same column of that leg. It then jumps out to a completely different column, column 26. And then we've got one of our wee wires in column 26 leading back to the ground, which is on the other side of the T connector thing, so it's a completely different set of columns and it's leading back to ground. So hopefully that is our circuit, and it means that the 21 pin, when it's on, the LED will be on, and that's what we're hoping to do in Scratch. Okay, so let's plug it all back in again. What are these things called?
Wires? But
Do you remember?
They're actually called wires.
Oh man, you do. Your memory is a
rusty bucket.
It is a rusty bucket. Right, so
I really did tell you my memory is a rusty bucket.
right, fair enough. Okay, so everything's plugged back in again.
Ooh.
That's turned on. Can you, Theo, turn on the, let's see what happens here. Can you turn on the Raspberry Pi? Right, first thing was successful, it didn't blow up, so that was good.
Woohoo! Then we need to turn on.
So hold on, yeah, turn on that. I'm going to zoom the camera in to the actual circuit, so don't move the circuit. Oh, well, it's hard to know whether this will light up at all because it's kind of not in the dark, but let's see, here we go. Okay, hold on. We'll hit record on the little recording device as we get the screen. Go into Scratch. Now this is where things get even more complicated if they weren't complicated enough.
Yeah.
So maximize
So
Scratch.
I'm just gonna check if.
No, don't open the other thing. I don't want to open the other thing. Oh, maximize that. Nope, not that.
Whoops.
Get rid of that. Maximize that window, yeah. So we've got Scratch at full size. So we click on the wee cat. Well, I don't know whether we needed to do that, but so the reason why we upgraded Scratch at the start was that we wanted the ability to connect to the GPIO connectors of the Raspberry Pi, and that's what we're going to use to control our LEDs. So well done, you've taken out a green starter. No, don't take this out, because what we're gonna do is we're gonna control the GPIO sensors, okay? So the first thing I need to do in the edit menu, now that we've upgraded Scratch, we've got start GPIO server, so just choose that. We could also broadcast to get
Dad,
that.
I changed its name when you weren't looking.
Thanks. So if you go into the control menu, basically all the stuff that connects the GPIO server is really broadcasting, okay? So let's drag a broadcast there, and it's all done through the naming of the broadcast, whatever you put in here, okay? So we have to name these very specifically. So the first thing is
Cat skills.
no, you can't call this randomly. You have to call it something very specific so that it connects and does the right thing according to the GPIO connector. So that first of all, we need to configure our pin 21 as a type of pin. So is it an input pin or is it an output pin? And because we're wanting to see output, wanting to see the LED light up, it's an output pin. Okay? So if you type in config FIG and then the number of your pin, which is, oh no space.
4.
No, it's not 4. What pin did we connect it to, the LED?
21.
Okay, type 21 then. And then out. No, don't hit return. Out, OUT. No spaces in any of this. So we're broadcasting and we're saying configure pin 21 to be output, okay? And hit OK. Okay, so that's broadcast, and that says, it tells it that pin 21 is now an output pin. If you run it, nothing happens. Okay, fair enough.
Yeah.
So, next thing is another broadcast. And if this doesn't work, I'm going to cry and we're going to have to go back to version 1. So, the next message is GPIO. And that's the name of the mechanism we're using to connect out. And we need our pin number. Remember what it was?
21?
Yeah, no spaces again. And then on, because we want it to go on. And hit OK. Now run the whole thing now. Oh, what happened? What happened?
What happened? The light! The light!
Oh,
the
watch.
light!
And I'm zoomed in on that, so hold on, you hold it up there.
The light!
Yeah, so hold it, put it down again. You're out of camera, just leave it there, that's perfect. So the light, if you hold your hand behind it, actually hold it behind the light, you can see the light lit up. So with our GPIO
It's
21 on, our wee light lit up, how do you think we turned off?
in broadcast GPIO 21 off.
Yeah, let's try that. So go on, drag a broadcast out. Do you want to maybe drag it somewhere else so that you can just click on it? Do you see what I mean? No?
GPIO 21.
Yeah, OFF. Okay, now the trouble is you've gone on and off together here. Well, hit green flag. Oh, you see it went off. Click it again. No, it's not even going on and off again. Because, exactly, that's perfect, man. So now you click that. Just, no, keep it away from it. Keep it away from the other block. And just click on it on its own. Click on it on its own. You see? So you can have those separate.
Cool.
And click it, so click that one again. So using your Raspberry Pi and the Scratch programming language, you are turning on and off an LED. Do you feel you've accomplished something? Perfect.
Okay, now what do we need to do?
Well, now we need to maybe introduce a switch and see whether we can get a switch.
What's exactly a switch?
What's a switch? What's a switch that's in this?
Oh, you mean like a button?
Button. So you take that and hold it in front of the camera, which is very zoomed in there. So,
where do I put it?
well, no, you don't connect into that while it's actually running, because that will be that will be bad. So let me zoom out a wee bit here, man. I just wanted you to hold it up to the camera. Okay, so that's a wee switch which also came with our Vilros kit, and that the LED was an output device. What do you think the switch is?
An input?
Yeah. So this is for input. So the reason for that is that you are reading whether the switch is clicked or not, and the computer's reading that, so it's not input from the computer. Output, the computer's outputting the fact that the LED light's on, and that is output. So will we stop and leave it till next time, or will we do it now?
Probably stop.
Okay, let's stop now.